I want to warn you guys that this is not super. Here we go. Sometimes, when you evaluate a definite integral, and you try to work things out, you have to do a substitution rule. And you know how you always got to plug it back in at the end? There's kind of a short way of evaluating a definite integral when you have substitution. And this is what we do. Sometimes we change that. Instead of being an f of x function, sometimes we change the variable to u, right? What happens is when you change it from x to u, the bounds of integration also change. And they change to this. U of a and u of b. There's nothing mind-blowing about this, but it is somewhat helpful. Hello! So nice of you to join us today. Hold on, let me see if I have everybody here. Derek, Robin, Corbin, Ben, Andy. Yep, got them all here. Thank you. All right, we'll hand those out. Remind me, guys. Lizen. Okay, so let's see exactly what we do here. We first start by finding this is a definite integral because it has bounds, 0 to 2. If you want to find this definite integral, I start by finding an appropriate antiderivative. If you want to find this antiderivative, you have to use substitution. What should I choose u to be? X squared plus 3. That means that du is equal to 2x dx. I don't have a 2x dx. So I can divide by 2. I get 1/2 du is equal to x dx. I have an x dx, right? So what I'm going to do is I'm going to rewrite this integral 1/2 times the integral. I don't have to write an x. I don't have to write a dx. I have to write a u to the 4th du. Now hold on. What didn't I include there? The 0 or the 2, right? Instead of putting a 0, I put in 0 squared plus 3, which is 3. And instead of putting a 2, I put in a 2 squared plus 3, which is 7. So now I'm going to do this. So instead of actually, well, you'll like this, watch. What's the antiderivative of u to the 4th? Over 5 multiplied by 1/2 is over 10, right? And I'm going to evaluate that then at 7 and 3. If I did this switch up here to 7 and 3 as opposed to 0 and 2, I could just leave it as u. I don't have to plug in that x squared plus 3 back in. Yeah, so we could just go to work from here. Yeah, 7 to the 5th over 10. Whatever that is, minus 3 to the 5th over 10. So I'll go to my calculator. So I've got 1656.4. Now, I want to write one more expression here so that you understand exactly what happened. U to the 5th over 10 evaluated at 7 and 3 is the same thing as x squared plus, what do we have? X squared plus 3 to the 5th over 10 evaluated at 0 and 2. So those are the same. You sure could do it like that. If you wanted to just do the problem like that, that's fine. But on the test, what I'll be asking you to do is there's one portion, it's on your study guide as well. It says evaluate the definite integral by substituting the bounds of integration. And what that means is I want you to just do this. So technically we're not doing anything new. We've always been able to evaluate that integral. The difference is instead of doing a substitution back in, I just substitute the bounds. And is it super useful right now? Well, kind of. There are other areas as you go down the road where this is a very useful technique. I'm just saying that those two are equal. If we would have substituted it back in, then your bounds would have been 2 and 0. Any questions? Okay. All right, let's do the next one. That's all I have for today. Give you guys a short assignment. Tomorrow we're going to review. We're going to do an activity in class. Monday will be entire study guide day, and then Tuesday will be test. A lot of you guys handed in 1 through 38 yesterday. By tomorrow, I definitely want that 1 through 22, and you should have 53 and 54 as well. And then by the rest, by test day, we should have the rest. I'll put that on the board today. Okay, so here we have pi over 2 and 0, sine of the third x, cosine of x. This is very good. U equals sine of x. So du is equal to positive cosine of x dx. Do I have a cosine of x dx up there? I do. It's right here. So I can put du in that place. So my new integration will be u to the third so u to the third du, right? That's my new integral. I have to put in my bounds now. Right. What is the sine of pi over 2? 1. What is the sine of 0? So now that's the integral that I can work with. What's the antiderivative of u to the third? U to the fourth over 4, evaluated at 1 and 0. That's it. So the only trick that you're finding out is how to change your bounds of integration through substitution. Everybody got that? And that's it. That's it. Okay, let's get you a couple problems to practice, and you guys can have the rest of the hour to work. So I think that these are good problems to check. 5 problems. You guys, I want you to understand that you could do these problems without substituting the bounds, but that's not an option. I want you to substitute the bounds of integration because I expect you to do it on the test. Okay? After this, you have... Am I correct in saying that your study guide is pretty lengthy? So having this weekend, to work on that, and Monday in class, tomorrow we'll review some stuff together. That's helpful, right? Okay, so you got half an hour to work. Go.